Welcome to your study part. And today we'll be considering chemistry. So today's subject is chemistry. Good evening. Get your pen, get your book, and be very attentive. This tutorial is basically for O level, Jamb, UTME, WAEC, NECO, GC, all of them. We'll be considering them stepwise. That means we'll be considering topic by topic. We'll take it from the first topic. But let's start off. Chemistry. Chemistry, all know is a science subject, right? What exactly is chemistry? Chemistry is a branch of science that deals with the study of matter. That means everything in chemistry is about matter. Everything, the calculation, the theory, all aspects of chemistry is about the study of matter. So we talk about the composition, right? We also talk about the structure, interaction, and also transformations that involves matter. For O level, chemistry can be divided into these aspects. Chemistry actually can be divided into more than these aspects, but for O level, we stick to general chemistry, inorganic chemistry, and organic chemistry. There are also several branches of chemistry like analytical chemistry, environmental chemistry, chemical kinetics. We also have physical chemistry, but for O level, we'll be considering general chemistry, inorganic, and organic. When we say general chemistry, what comes to mind? Topics like separation, topics like compound and mixture, periodic table, and a whole lot falls under general chemistry. Separation, compound mixture, matter, volumetric analysis, acid and base, oxidation and reduction reaction, they are all under general chemistry. When we talk about inorganic, we're talking about the chemistry of elements. That means chemistry of hydrogen, the chemistry of halogens, the chemistry of nitrogen, chemistry of carbon, chemistry of oxygen. So we are talking about elements, considering them individually, right? And so when we move to organic chemistry, what comes to mind? Hydrocarbons. So that's about it. Hydrocarbons, you have your alkanes, alkenes, alkynes, alkanol, alkanone, alkanoic acid, aldehyde, ketones, they're all under organic chemistry. So we'll be starting off with the general chemistry. And the first topic we'll be considering today is atom. Atom. And so today's topic will be under atom. Atom. I'm sure this word is not new to any one of us in this class. So what's an atom? An atom is the smallest part of an element that can take part in a chemical reaction. The smallest part, you can say particle of an element that can take part in a chemical reaction. Smallest part of an element that can take part in a chemical reaction. That's the definition of an atom. Atom also have subparticles. Atom have subparticles. And we know the subparticles of atom. You have the proton, you have the neutron, and you have the electron. So these are the what? Subparticles of atom. We know atom is smallest part of an element. So the beginning is elements. This is starting point. Element, smallest part of an element is atom. But atom can also be subdivided into subparticles. That's the neutron, the proton, and the electrons. These are, some are charged, some are not charged. For proton, it is positively charged. Neutron is neutral, whereas electron is negatively charged. So proton is positively charged, neutron is neutral, and electron is negatively charged. And these are the subparticles of atom. Let's consider what we call atomic number. But before then, let's just take a look at the structure of atom. Don't forget that atom is the smallest particle of an element. And so, the structure of an atom, we have this. Then we have this. Let me redraw that. So this, let's denote it to be the proton. This X sign, the neutron, whereas this electron. And this entire would be the nucleus. That means the proton and the neutron is found inside the nucleus, whereas the electron orbits around the nucleus. The neutron, which is neutrally charged, proton, which is positively charged, is found inside the nucleus, whereas electrons, which are negatively charged, orbit around the nucleus. So let's move on to atomic number. What's the definition of atomic number? Atomic number is the number of proton of an element. The number of proton in the nucleus so we can say atomic number is the what? Proton number. Atomic number is equals to what? Proton number. For a neutral charged atom, that means for an atom that is neutral, an element that is neutral, proton number is equals to electron number. Example, hydrogen. You know, it's the first element on the periodic table. So this, since it's neutral, the proton number is 1, the electron number is also 1. Let's consider another element, calcium. Calcium is the 20th element on the periodic table. This is the proton number and is also the electron number because this calcium atom is neutral. But if we get something like calcium 2 plus and you are given 20, this 20 is the proton number, but because this calcium is not neutral, it carries a charge, the electron number is not 20, rather it is 20 minus 2. This plus 2 signifies that it has lost 2 electrons. And since 2 electrons are missing, we'd have to deduct that from this value. That means 20 minus 2, which will give you 18. Let's Let me give another example. For chlorine, chlorine is the 17th element on the periodic table. So the atomic number is 17. But if it has a negative sign here, that means it's negatively charged. That means it is an anion. It has what? Received one electron to itself. If I'm asked the proton number is 17. Electron number would be 17 plus 1 because it has received one electron to itself. It will be 17 plus 1, and that would be 18. So the electron number is 18, whereas the proton number is 17. But if I'm just given chlorine 17, the proton number will be 17. The electron number would also be 17 because it is neutrally charged. Let's consider mass number. Mass number. What's mass number? Mass number is the sum of the proton and the neutron of an element. The sum of the proton and the neutron in the nucleus of an element. Don't forget the structure of atom I drew. I made mention that both the proton and the neutron is found in the nucleus. So mass number is the sum of the proton and neutron in the nucleus of an element. So mass number would then be equals the proton number plus the neutron number. So if I'm given calcium, or let's start from unknown, an atom X, and I was told this is 17, this is 37. This is the atomic number, whereas this is the mass number. This is the atomic number and this is the mass number. And so we are told that the mass number is 17. Mass number rather is 37. Atomic number is 17. Calculate the neutron. Since I know that mass number is the sum of the proton plus the neutron, I can calculate my neutron. Since it will just be 37 minus 17, and this will give 20. Another element, 618. I know this is my atomic number and I know this is my mass number. This is neutrally charged. So proton number is 16. Neutron is also 16 because it doesn't carry any charge. Whereas the mass number is, proton is 6, neutron is 6 from here, and mass number is 18. But if I'm given 6, 8 minus, it carries a negative charge. That means it is an anion. It has received one electron to itself. Proton number would also be 6, but electron would not be 6 because of this charge. Rather, it would be 6 plus 1, which would be 7. And mass number would also be 18. What would be my neutron number? My neutron would be the mass number minus the proton. Mass number is what? 18. Proton is 6. Neutron will then give us 6. Let's take a couple few examples. Let's try for positively charged atom. This is 6, this is 18, this is X, and you have a positive 2 plus. My proton number is still the atomic number, which is 6. This element carries a charge, so my electron will not be 6. Rather, since I know it carries charge and it is positive, that means it's cation. And cations do what? They give out electron. This number shows the number of electrons it has given out. Here it is 2. But if it is negative, 2 minus, that means it has received 2 electrons to itself. And so electron number would be 6 minus 2, because it's a cation, this would be 4. Mass number is still 18. Neutron is then 18, which is the mass number, minus the proton number, which is 6, which will give us 6. All right. So let me write a table that we can practice with in order to solidify our knowledge on that. Okay, particle. Neutron. Electron. Proton. Mass number. W2 plus, X2 plus, Y, and Z. This is 12. This is blank. This is blank. This is 12 as well. Blank, blank, 13, 11. This is blank. This is 8. This is blank. This is blank. This is 24, 16, 27, and this blank. This is a typical exam question. If you are asked to complete the table, So let's take it one after the other, starting from W2 plus. 2 plus signifies that it is what? It is a cation. That means it has given off 2 electrons. So, solution. W2 plus. What information were we given? We were given the neutron number to be 12. We are given the mass number to be 24. And so from this information, we can calculate the proton number, because we know that mass number is equals to proton plus neutron. So it then be, since mass is equals to proton plus neutron, mass number is 24. We're not given proton, but we're given neutron. Make this subject formula 24. This will cross to the other side, minus 12 equals to P. 24 minus 12 is 12. That means P is 12. That means for here we can write 12. No, sorry. We calculated the proton number. Proton number is 12. Let's go back to the particle. It is not a neutral atom. If it was a neutral atom, proton number would be equals to the electron number. But since it's not a neutral atom, rather it carries a charge, we'd have to respect that charge. and it is 2 plus. That means that's giving off 2 electrons. Basically, it will be 12 minus 2, which will give 10. That means the number of electrons is 10. So we are good with that. Let's move on to the second. Let this be a negative sign. X2 minus. We're given the proton number to be 8. So proton 8, mass number 16. From here, we know our mass number, we know our proton number. We have to calculate the neutron number and the electron number. But we all know that mass number is equals to the number of proton plus the number of neutron. This is 16. This is 8. So we can calculate this. This will be 16 minus 8, which is n. So n is 8. So our neutron number is 8. So we can write 8 here. Then let's move to the number of electrons. The number of electrons would have been 8 if this didn't carry this charge. But since it carries the charge, we have to respect that charge. And negative sign shows that it is anion. It has attracted 2 electrons to itself. So it will be proton number plus 2. So electron then would be 8 plus 2. And that is 10. So this is 10. Let's move to third one. As Y. We're given electron number to be 13 and mass number to be 27. This is a neutral atom. And since it's a neutral atom, the number of protons will be equal to the number of electrons. So the proton number would be 13. Since it's a neutral atom, then we are left with calculating the number of neutrons. And we know mass number is equal to the number of proton plus the number of neutrons. We know our mass number to be 27, proton to be 13 plus n. So this is 27. This will cross the equality sign, then it will be negative equals to n. Neutron then will be 27 minus 13 is 14. So this is 14. This is 13. And this is 14. The last one. That's Z. We're given the neutron number to be 12, the electron to be 11. This is a neutral atom. And since it's a neutral atom, the number of electrons is equal to the number of proton. That means the proton number is 11. We are left with calculating the mass number. So mass number is proton plus neutron. Proton number is 11. Neutron number is 12. 11 plus 12 will give 23. And so this is 23. And the proton number is 11. So we've completed the table. Let's move on to another concept.